Hello everyone, welcome to the 38th lecture in the series. In this lecture, we are going to learn how this greedy approach to problem solving can be used for solving the problem of job sequencing with deadlines. Of course, in some books, we could even see this problem being spelt as task scheduling. You know very well, in the context of operating system, any job that is submitted to the CPU for execution can be again broken down into sub problems, wherein we call each of those sub problem as a task. So, as such, we are going to see how jobs could be sequenced, and given the jobs with deadlines, we need to schedule those jobs to either a single machine, and if in case there is some conflict between them, then we may have to deploy more number of machines. So, I will be telling you first how task scheduling could be done with some slides, and then we will be specifically looking at this job sequencing problem with deadlines and how this problem can be solved given a single machine for executing all those jobs. So, first let us see what this task scheduling problem is. Consider that we are given with a set T, and that set T contains n number of tasks, and for every task I, we have a start time Si and we have a finish time which is Fi, and we have to perform every task on a machine, and let us assume that that machine will execute only one task at a time, and we assume that every task will run for 1 unit time, and we say that two tasks I and j are non-conflicting if the finish time of the first task, which is I, is less than the start time of the second task, which is j. So, we say that Fi is less than or equal to Sj, which means that the job 1 or task 1 finishes well before the second task starts, or in other words we can say that the finish time of job j is less than or equivalent to the start time of I, which means the second job finishes first before the first task. So, if two tasks have their start time and finish time non-overlapping, we call them as non-conflicting tasks. If two tasks have different start and finish times, then it is obvious that those two tasks can be scheduled on the same machine, because they use that machine at different time periods. So, two tasks can be executed on the same machine only if they are all non-conflicting in nature. So, this is one of the constraints that we need to verify before scheduling the tasks onto the same machine. So, given this constraint, the task scheduling problem is to schedule all the tasks in the set capital T onto a fewest number of machines possible, and that too in a non-conflicting way. So, using fewest machines is one of our constraints, and we can schedule the tasks to a machine provided they are non-conflicting in nature, right. So, here you could see that we have different time periods, and we have used 3 different machines, and we have some 6 or 7 number of tasks scheduled on to 3 different machines at different time periods. So, our problem is how we actually schedule these tasks on to different machines. So, for solving this kind of problem, we use a greedy approach to problem solving. So, we call this algorithm as a task scheduling algorithm. The algorithm takes as input a set of tasks, and for every task we need to have a start time and a finish time, and output will be a non-conflicting schedule. So, the output of scheduling algorithm is a schedule, and the schedule will include tasks in the set T, and the schedule is supposed to use a minimum number of machines to schedule all those tasks and see that all those tasks get executed on the machine. To start with, let us assume that there is we initialize the variable m to 0, where m denotes the optimal number of machines that are required for scheduling all the tasks in the given set T. We have to repeat this process till our task queue is empty or task set is empty. So, while T is not equivalent to null, we do the following steps. First, we remove any of the task I with the smallest start time Si. So, we pick up a task with the start time Si, and that should be the smallest of all, because that is the task that has to be executed first, but otherwise we may exceed the time, right. So, we pick up the one whose start time is the smallest. Say for instance, if we have 3 tasks to be completed before 1 p.m., 2 p.m. and 3 p.m. ultimately, if the time is 12:35 p.m., then ultimately we may pick up the job that has to be completed before 1 p.m. first, right. That is the general rule. So, that is the same thing which we take up as the first step in this algorithm. And then we check if there is a machine J with no task conflicting with task I. So, we have to ensure that there is a machine and that machine is free by that time, and for that we verify whether there is no other task conflicting with the chosen task I. If so, we schedule the task I on the particular machine J. Otherwise, what we have to do is that just because the set task has to be completed before 1 p.m., then we have to take up a new machine. So, we say that m becomes m plus 1 and schedule the task onto the new machine. If suppose the existing machine is free, then we will be using it, or else we will be assigning the task to a new machine. So, our objective here is to complete the task before the said finish time. And so, here when we analyze the task scheduling algorithm, initially we begin with no machines and we try to pick up the tasks in a greedy fashion. So, we order up all the tasks according to their start time. Say for instance, we have 3 jobs or tasks that are to be started by 1 p.m., 2 p.m. and 3 p.m. Naturally, we choose the task that has to be started by 1 p.m. first if the time now is 12:35 p.m. For each of the task I, if we have the machine that can handle the particular task I, we will be scheduling that particular task onto that machine. If in case the particular machine is not free or handling or executing some other task by that time I intend to start the task I, then I have to think of allocating a new machine to schedule my task I onto it. So, we will be repeating this greedy process until our task set becomes empty, until all the tasks in the task set are completed. So, we will see an example of how this task scheduling algorithm actually works. Let us assume that we are given with a set of n number of tasks, and every task has a start time and a finish time, and always the start time of any task is less than its finish time. Now, we have ordered all the tasks according to their start time. So, here you could see that there are 2 tasks that start at 1 p.m., one task that starts at 2 p.m., one that starts at 3, another starts at 4, another at 6 and another at 7. So, we have ordered them according to their start time. But as you see, the first two tasks start at 1 o'clock, but the first task finishes by 4 and the second task finishes by 3, right. So, this may differ, their finish time may vary. We have ordered it according to their start time alone. Our goal is to perform all of these tasks with the minimum number of machines with this particular problem. With this task scheduling problem, our goal is to perform all the tasks, but we have to use only a minimum number of machines. So, first let us assume that we have taken up the first task, which is which starts at 1 o'clock and ends at 4 o'clock, right. So, we have scheduled the task onto the first machine. And the next thing is we have to run the second task, but that the second task start time is also 1 o'clock, but you know the first machine is not free by that time, it is already allocated with task 1. So, we allocate a new machine and we schedule the second task onto the second machine. So, the second task runs from 1 to 3 on the second machine. The third task is 2 to 5. So, it is supposed to have started by 2 o'clock, but you know by 2 o'clock both the machines 1 and 2 are occupied. So, we deploy a third machine or add a new machine 3, and we put up the third task that starts at 2 o'clock and ends at 5 o'clock. Now, we take up the fourth task. The fourth task is supposed to start at 3 o'clock. You know by 3 o'clock the machine 2 is free, and so we schedule that task onto the second machine. So, it runs from 3 to 7 on the second machine, and meanwhile we have another task that starts by 4 o'clock. By 4 o'clock you know machine 2 and 3 are occupied while machine 1 is free. It has just serviced the first task, and so we schedule the fifth task onto machine 1. And then we have the sixth task, which is 6,9, that is supposed to start by 6 o'clock, but by 6 o'clock you know machine 1 and 2 are occupied, and so we schedule it onto the third machine. And then we move to the last task, which starts by 7 and ends by 8, and by the time we have two options, either to choose machine 1 or 2, and we have allocated task or scheduled task 1 onto machine 1. So, this is how the scheduling of tasks or the schedule is prepared with the help of this task scheduling algorithm. So, now we move on to the next type of problem, which is the job sequencing problem given the deadline for every job. So, let us first define the job sequencing problem with deadlines, then we will see how this problem could be solved with greedy approach. So, here we have n number of jobs to be processed on a machine. So, this is to be underlined. Here we are going to process n number of jobs, but we are going to make use of only one machine. Every job has a deadline associated with it, and the deadline is given by di, which means, and deadline di is always greater than or equal to 0. So, deadline in that sense it actually means its finish time, which means the particular job I has to be completed before the set deadline. Say for instance, if I say the deadline of job 1 is 3, it means the job 1 is supposed to get completed before 3 p.m. and every job will have a profit associated with it, which is pi. So, this profit can be earned only if the job is completed by its deadline, otherwise there will be a penalty. So, we say that in order to maximize the profit, we need to ensure that every job is completed well before its deadline. The job is completed if it is processed on a machine for a unit time. So, here we make an assumption that every job requires a unit time for its execution or completion, and only one machine is available for processing the jobs, and at a time the machine can process one job. So, these are some of the constraints as well as the things we have at the time we have the job submitted. So, a feasible solution for this problem is a subset of jobs such that every job is completed by its deadline. So, this is the solution we expect from the job sequencing problem, for which we are going to use the greedy approach. And now we look at what an optimal solution for this problem should be. So, an optimal solution should be one of these feasible solutions that maximizes the profit. So, let us see with an example how this could be solved. Let us consider that we have 4 number of jobs, and those 4 jobs have some profit which are 100, 10, 15 and 27 respectively, and all those jobs have some deadline associated with it, which are 2, 1, 2, 1 respectively. So, now let us consider how this job sequencing can be done considering the deadline. Now, let us say that we have one of the feasible solutions as 1, 2, which means we are out of the 4 jobs we have on hand, we say that taking up jobs 1 and 2 is the feasible solution. And now we look at its processing sequence. So, processing sequence is mainly decided by its deadline. So, we actually take the jobs 1 and 2, but you see the deadlines of jobs 1 and 2. Here the deadline is the second job should be completed before 1 o'clock, whereas the first job should be completed before 2 o'clock. That is why we reverse the sequence 2, 1. So, if I do this in order, that is the second job first followed by the first job, then I need to verify how much of profit I would get if I schedule it this way, right. So, in order to compute the profit, what we have to do is that we have just two jobs in our feasible solution, we just sum up their profits. So, the profit of first and second jobs are 110 respectively, we sum it up to get the profit value of 110. Next, this is one of the feasible solutions. So, we are considering a greedy approach. So, at every iteration we look at one feasible solution, and that is going to be the locally optimal solution, and our objective is that this locally optimal solution will naturally push us towards a globally optimal solution. And so, now we have the next feasible solution, which is 1,3, that is taking up the first and the third job. So, here as you see their deadlines, first and third job both have their deadline as 2. So, there is no matter even if we do first job first followed by third job or third followed by first, since they both have the same deadline. So, considering this as a feasible solution, the profit that we could get is 100 plus 15, which is 115 here. So, another feasible solution could be 1,4, but we reverse the processing sequence just because fourth job's deadline is 1, whereas first job's deadline is 2. So, we reverse the processing sequence, but if we do compute the profit of this feasible solution, it is 127. Likewise, for all the feasible solutions that could be made up for this particular set of jobs, we compute the profit value and then we report one as the global solution or globally optimal solution, which in our case is picking up jobs 1 and 4, and that too doing 4 first followed by 1. So, this is how your job sequencing problem with deadline actually works, and this is how we solve it using the greedy approach. So, in order to get the optimal solution for the job sequencing problem using the greedy algorithm, these are some of the steps that we take up. The first is we have to consider the jobs in the non-increasing order of their profit, subject to the constraint that the resulting job sequence J is a feasible solution. So, we know very well that if we are using the greedy approach, we need to find the optimal solution to all of its sub problems, and that will ultimately lead us to the globally optimal solution. So, we order up the jobs in the non-increasing order of their profits, and we ensure that the constraint that is the resulting job sequence is a feasible solution. In the example that we considered before, the non-increasing profit vector should be something like this. We have to sort up all the jobs according to their profit. So, you know, the first job had the highest profit, so 100, followed by a fourth job whose profit is 27, and likewise the other two jobs and their profit values are put up in non-increasing order. So, now we have to use this greedy approach for problem solving. So, the reason why we do this arrangement first is that if in case the number of jobs is less, then we could try up all those possibilities just as we did with the previous example. But if in case the number of jobs to be scheduled or handled is more, then it is not feasible to handle or consider all the possibilities one after the other as we did earlier. So, here what we do is that we first order up the jobs according to their profit, and then we check whether it is a feasible one. So, one of our feasible solution could be like taking only the first job in our schedule, and so as such taking the first job alone is also one of the feasible solutions because it yields the maximum profit of 100. So, next is that we check whether we could add up one more job to this schedule, which is 4. So, even then we do not go out of the deadline, and so taking up 1 and 4 is also a feasible solution, but only thing is that their processing sequence has to be reversed as 4, 1 because the fourth job has a deadline of 1. Next, we check whether one more job could be added up to this schedule, like whether we can have 1, 3 and 4. You know, their deadlines do not match. The third job also has a deadline of 1, the first job also has a deadline of 1. We cannot take up both the jobs at the same time because we have only one machine. So, taking up the third job while handling first job is not at all feasible. So, we say that it is a not feasible solution. And the other way around is we think of considering a second job also after first job, but taking up a second job is not feasible because we have already taken the fourth job as one of the feasible solutions, and the fourth job has even more profit than the second job. That is why we have considered it first. And if we have to take the second job, that is not feasible because both the jobs have the same deadline and we have only one machine. So, running 2 and 4 at the same time is not at all possible. So, we end up saying that for this particular 4 jobs, our schedule will have only 2 jobs which are 1 and 4, and that is going to be the optimal solution for this particular problem. So, this is the greedy algorithm that we use for proposing the solution for the job sequencing problem. First is that we sort all of the jobs in decreasing order of their profit, and then we initialize an array of time slots. The size should be equivalent to the maximum deadline, and initially all of them are set as free. Now, what we do is that we choose a job from the sorted list, and we have chosen the job whose profit is the maximum. Then what we do is that we find the latest available time slot that is less than the job's deadline. This is the very important thing that we need to adopt. So, we take the job with the maximum profit, and then we try to put up the job in the schedule in such a way that it is less than or equivalent to the job's deadline. If we are able to find one such slot for that particular job, then we assign that job to that slot and we mark that slot as occupied, and then we are supposed to keep track of the profit gained so far, and we will be adding the job's profit to the total profit. Initially the total profit would be initialized to 0, and finally we return the list of scheduled jobs and the total profit. So, this is how your greedy approach to the job sequencing problem works. So, we will see this with an example. Probably you will be understanding this better. Let us consider that we have 5 number of jobs. So, I have given 5 number of jobs, each of them having different profits and each of them having different deadlines. So, I have sorted up all the jobs according to their profit. So, as you know, the first step that we have to adopt is we have to choose the job with the highest profit. So, naturally we have to move with the first job first. So, before that what we need to see is that we have this particular column lists the jobs that are all considered to be part of the solution, and these are all the slots assigned for the particular job, and this is going to be our solution, and I mean the schedule, and this is the total profit. Initially our solution is empty and our profit is 0. As such, since job 1 has the highest profit, I am taking it up, and we have the deadline for job 1 as 2, which means that the job 1 has to be completed before 2 o'clock, let us assume. So, what we do is that we have 2 slots, we have assumed that every job takes up unit time. So, what we can assume is that we have till the deadline of 2, we have 2 slots left, one is between 0 and 1 and another one is between 1 and 2. Since job 1 has to be completed before 2 o'clock, I am using the slot as this 1, 2, right. So, every time I try to fit the job in the schedule in such a way that the job's deadline does not exceed the available slot, right. We do not exceed the deadline, and so I am assigning job 1 for in the machine, I mean with the between time 1 and 2. So, the total profit that we have gained with the scheduling job 1 is 20 at this moment. So, next I am picking up job 2. Job 2's profit is 15 and its deadline is also 2. So, here as you see its deadline is also 2, which means that job 2 should also be completed before 2 o'clock. But we have only one machine and that machine is occupied from 1 o'clock to 2 o'clock, but it is free before, that is between 0 and 1, that is the first time period, it is free. So, I am assigning job 2 to the first available time slot. So, by now our schedule has 2 jobs, job 1 and job 2, and during the first slot I will be running job 2 and during the second slot I will be running job 1, and the total profit gained so far is 20 plus the profit of the second job, which is 15. So, the total profit is 35. And next we consider the third job, whether that can be included as a part of our schedule. But when you look at its deadline is 1 o'clock, but you know by 1 o'clock the machine is not at all free. So, we cannot consider job 3 in our schedule. So, as such the profit is still 35, we avoid taking up job 3. Next we try with job 4. So, the job 4's deadline is 3, which means it is supposed to get completed before 3 o'clock. You know the machine is occupied till 2 o'clock. So, I fix up the slot 2 to 3 for job 4 and I add up its profit to the total profit, which is 35 plus 5, 40. Next I think of adding the fifth job here. It is mistakenly put as 4, but it is 5. So, when I take the fifth job here, you see fifth job's deadline is 3 o'clock, but by 3 o'clock the machine is already occupied. So, we cannot have the fifth job in our schedule. So, altogether the solution for this problem is with I mean it has only, the schedule contains only 3 jobs, which are J2, J1 and J4, and the total profit earned is 40. So, this is how your we get optimal solution for the job sequencing problem by following the greedy approach. Let us consider one more example. So, here you see we have 7 number of jobs and I have given their profits as well as their deadlines, and I have sorted up all those jobs according to their profit. So, in order to get solution for this problem, what we are supposed to do is that let us take the first job because it has the highest profit and but its deadline is 3. So, here what I have done is that as every job takes up a unit time, I have just marked up the slots as 0 to 1, 1 to 2 o'clock, 2 to 3 and 3 to 4 o'clock, and the first job's deadline is 3. So, I actually choose the slot till 3 for the first job, because the reason for choosing the time slot 2 to 3 for the first job is that we may have some other jobs whose deadline falls well ahead, right. So, only if those slots are kept empty, then we will be able to accommodate some other job with slightly lesser profit on those slots. That is the reason why we put up job 1 in the third slot instead of taking up the first 2 slots. So, since job 1 demands us to complete the job before 3 o'clock, we just put up in the available slots, and the reason for choosing this slot is that if we have kept the earlier slots free, then some other job with higher profit, not higher than this, but a better profit could be accommodated in that place. So, somehow even if you put up job 1 here, we are going to gain the profit anyhow, because we are completing the work well within the deadline. And the next choice is that we take up the job 2, it is supposed to get completed by 4 o'clock. So, we put up this slot for job 2. Next we pick up job 3, but you know job 3's deadline is also 4 o'clock, but you know by 4 o'clock the machine is occupied, but we can very well accommodate job 3 in any of the earlier slots, because job 3 demands completion by 4 o'clock, but it is not an issue even if job 3 is completed between 1 and 2 o'clock, and so we use this available slot for job 3. So, altogether the profit gained with the 3 jobs is 90. And now we move to the next job, which is job 4. So, we have taken it up, but you see its deadline is 2 o'clock, and we look for any of the free slots before 2 o'clock, and we have 1 slot left, and so we allot this slot between 0 to 1 for job 4. So, our profit would then become 90 plus 20, which is 110. So, next we move on to job 5. As such, job 5's deadline is 3 o'clock, we have only one machine, and by the time the machine is occupied. We have job 6 deadline as 1 o'clock, but by that time also the machine is occupied, and we have one other job whose deadline is 2 o'clock, but by that time also the machine is occupied. So, all those 3 jobs can never be a part of our schedule, because they are not at all non-conflicting, right. And so we just have only these 4 jobs as a part of our schedule, and that is our optimal solution. So this is how this greedy approach to problem solving works for job sequencing problem in order to get an optimal solution for the problem. So having seen how this task scheduling algorithm and job scheduling algorithm works and how this greedy approach is applied to it, now let us summarize what we have learnt so far. So the objective of this task scheduling as well as job scheduling problem is that we have to schedule the jobs in such a way that we maximize the profit, and we also have a constraint that all the jobs have to be completed well within the deadline, and we need to allocate jobs for every time slot available for the machine. And for solving this particular problem, we use a greedy approach, just because with greedy approach we always make a locally optimal solution at every point of time. In order to do it, we sort all the jobs by their profit. We arrange them according to the decreasing order of profit, and we try to schedule each of the job to the latest available slot. The reason for allocating the job to the latest available slot is that if some slots before those slot is left free, then that could help us to accommodate more number of jobs by looking at their deadline. And in order to select the job, we pick up the most profitable job first. That is the reason why we arrange the jobs in the decreasing order of profit, and we try to assign it to a time slot that is still free, and we prioritize later slots to leave room for others. So the jobs that are allocated first or allotted first I mean, they try to ensure that they leave up some of the slots for other jobs to get those slots used. And when we look at their time complexity, it is going to be of order of n into log n plus n into d. So here we do some sort of sorting as well as scheduling, and for that this time complexity is required, and we can optimize this process by using the disjoint set union, which we learned before. And this algorithm works best for problems where all the jobs take up an equal time. So we were making an assumption while solving this problem that all the jobs require the same amount of time, that is, we said they take up a unit time, right. And we also make an assumption that the deadlines are all known for us, and we are giving utmost priority to the profit, that is maximizing the profit, and that helps us in both scheduling the tasks as well as helps in better allocation of all the available resources. So having understood having learned the concept of job scheduling and task scheduling and how it could be solved with the greedy approach, now let us look at some questions to test our understanding of the concepts. So first question is that why do we sort jobs in decreasing order of the profit in greedy job sequencing algorithm? So here our objective is to maximize the profit. So always we make an attempt to take the job whose profit is more first, and that is the reason why we do this ordering. And what is the significance of assigning a job to the latest available slot? Say for example, let us assume that I take up a job whose profit is 25, and that is the maximum among the available profits. So naturally that is the first process for which I am going to allot the slot. And let us assume that the particular job has to be completed before 3 o'clock, and I have slots like 0 to 1, 1 to 2 and 2 to 3. In that case, I will be allocating that particular job to the slot between 2 and 3 to ensure that it gets completed before the deadline. But at the same time, I just omit up the slot 0 to 1 and 1 to 2 for the reason that if those slots are left free, then some other some other job with the deadline earlier like 1 o'clock or 2 o'clock could be allocated to those earlier slots. So, every time we allocate a job to a slot, we always stick on to the property that we allocate it only to the latest possible available slot. By doing this, we can try to accommodate more number of jobs into the available slots. The third question is, can this greedy approach guarantee an optimal solution if jobs take more than 1 unit of time, why or why not? So, this greedy approach cannot work or guarantee an optimal solution if we remove this assumption. So, only if this assumption holds, then we can make use of this greedy approach to solve this particular class of problem. And the fourth question is, if two jobs have the same profit, how should the algorithm decide which one to schedule first? Does it affect the total profit? So, if two jobs have the same profit, then we need to look at their deadline. And if we have to look at their deadline, and we have to allocate those jobs to their latest available slots. So, it does not, the total profit has nothing to do with the slot to which it is allocated. So, since they both have the same profit, it does not matter whether we pick up the job X or Y, and depending upon the available slot, we may be trying to either accommodate X or Y. If both the slots which X and Y demand are free, then we would be actually trying to accommodate both of them and to double the profit. Hope you might have understood the concepts of job sequencing and task scheduling, and how to make use of greedy approach with this particular lecture. Thank you for watching.